Hello. So this is a brief review for quiz 9. I'm saying it's brief because you don't really have any extra problems or anything to do. It's really just looking over your homework, looking over your daily lessons, and make sure that you actually understand them. So a couple things. So this is on a list that I'm going to give you in class, but if you don't have it, I'm going to read this here anyway. Understand the connection between f prime, and f double prime. So go back through your notes. Make sure that you know what are the connections between f prime and f double prime. If f prime is positive, what's that mean about f? It means f is increasing. If f double prime is positive, what's that mean about f? That would mean that f is concave up, f prime would be increasing, since f double prime is the derivative of f prime. Those connections, make sure you know really, 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 really well. There are a whole lot of questions on tests that are about this. Same thing about the connections between position, function, velocity, and acceleration. So sometimes graphs are given, sometimes algebraic functions. So anything on here, go through every single homework problem or test problem. I'm sorry, you don't have tests, but any homework and anything in the daily lessons involving those. That will be the biggest part of multiple choice. There are problems about optimization, but really there's like one as opposed to a whole lot of these ones. Average acceleration versus instantaneous. This for your response question. There's some stuff on this. Same thing over here. Rolle's theorem, mean value theorem, intermediate value theorem, extreme value theorem. These theorems, make sure that you know. When does Rolle's theorem apply? This is the one that a function has to be continuous, it has to be differentiable, and f of a equals f of b. If so, then someplace f prime of c equals 0. Mean value theorem. So I should put, Rolle's. I'll write that. So Rolle's, if a function is continuous, differentiable, f of a equals f of b. If all of those things are true, then there's somewhere where f prime of c equals 0. For mean value theorem, function has to be continuous and differentiable, and as soon as those two things are true, then there's somewhere where mean, the average rate of change, equals the instantaneous rate of change. So this would be average rate of change, slope of the secant is equal to the slope of the tangent line. Intermediate value theorem. Intermediate value theorem just requires that a function is continuous. Remember, if a function is differentiable, it's definitely continuous. Extreme value theorem. This one, you don't actually have to know the name of it as much as where absolute mins and absolute maximums can happen. So absolute mins and absolute maxes can happen, remember, on endpoints. If you are actually just given something, let's say you want to find the maximum velocity, and you're given a graph of position, know that you could always, so if you want to find the maximum velocity, but you're given some position function, you can take the derivative and then just check out the graph. Let's say the graph looks like whoop, there. Here's my maximum velocity. So use your calculator and do second, calculate, and then find the max, left bound, right bound. And remember that this one, if you're finding the actual velocity, that would be p prime of t, so that's your y value. Same thing if you're given velocity, let's say this was v of t, and instead you were trying to find maximum acceleration. That's what you'd be doing. Kind of all over the place in this one, but there's so many f prime, f double prime, and the same thing about position, velocity, and acceleration. So I'm coming back to this. What I do want to do on here, though, even though this is just a list of stuff that you make sure that you go through those problems, so I'm not giving you too many extra problems on this one. There's nothing designed to trick you on this. I am going to go through this one, at least a few of the steps. This was on your daily lessons, page 140. We did this before break, but I know lots of people didn't actually get through this because of, I don't know, it was the day before Christmas break and we only had a half an hour. So if you didn't, here it is now. So in the first one, find the average acceleration. So before I even start doing this, I just did what many of you are tempted to do, to rush down to this part. When really, I need to pay attention to some stuff up here. So a test plane flies in a straight line with positive velocity at time t equals minutes. Great, that's fine. But here, it says v of t is a differentiable function of t. That's really, really important because that only tells me that the function is, or not only tells me the function is differentiable, I also know it's continuous, which means that a lot of those theorems suddenly apply. Okay, the next thing it says for some values here, and it's given. Okay, so there will also be, like, let's say, I don't know, if you were talking about a car driving smoothly or something happening smoothly, that would be enough to tell you that the function was continuous and differentiable. There's no sharp turns, nothing crazy happening in it. So make sure that you're checking up there. Okay, so we've got t and we've got v of t. In this first one, it says find the average acceleration. V of t is given. Acceleration is the derivative of v of t. Average means we want to be doing this, where we say v of 40. Oh wait, I'm sorry, it says from 5 to 20. So v of 20 minus v of 5 over 20 minus 5. And this says calculator permitted. Tomorrow is also a calculator quiz. So make sure if you ever have to do a derivative and it just asks you to evaluate at a point, use your calculator. So this one's v of 20 minus v of 5. So v of 20 is 4.5 miles per minute. V of 5 is 9.2. 20 minus 5 is 15. I get negative 4.7 over 15. If you want to leave it like that, you can. Or if you want to say negative 4.7 divided by 15, it's fine, but I get this kind of crazy answer, this negative 3.1333333. Either you can change it to negative 47 over 150, or you can just keep it like this. I'm going to choose to keep it, but it says make sure I have correct units. The numerator here is the velocity. Velocity was given in miles per minute. The denominator, 20 minus 5, would be minutes. So my average velocity is negative 4.7 over 15 miles per minute, or miles per minute squared. So we did this one. And part B, based on the values in the table, on what intervals is the acceleration guaranteed? Hey, look, looks like we're going to have a theorem to equal 0. So if acceleration is equal to 0, that would really mean v prime of t, that's acceleration, is going to equal 0. Somewhere, as long as a function is continuous, and I can see it is because it's given. So I'm going to say v of t is differentiable therefore continuous. And because I'm talking about v prime equaling 0, I know I've got to say something about roles. If you wanted to, you could also use mean value theorem here. But v of t is differentiable, therefore continuous, so I'm saying that part. The other thing with roles, remember, is f of a is equal to b, f of b. So if I go up here and I can see where are these values the same, and I can see that that happens right here at 2.4, so between 25 and 30. Am I missing any other ones? I think that's it, between 25 and 30, because v of 25. So this is true. V of t is differentiable, therefore continuous. V of 25 equals v of 30. And I'm even going to say 2.4 equals 2.4, so I know for sure that's why they're equal. Therefore, roles guarantees such a value. And then if you notice, it doesn't actually, it just says to justify. It doesn't say what is the value of C. So I don't have to find that. I'm just saying, is there one guaranteed? Yep, there is, because V of t is differentiable, therefore continuous, and rules V of 25 equals V of 30. And I should say guarantee such a value on the interval 25 to 30. Meaning somewhere in between 25 and 30. Not 25, not 30, but somewhere in between. V prime of t is going to equal 0. Okay, next one. Does the data represent velocity of the flame moving away from its point of origin or returning to its point? So is this going to be, let's going to go through this a little bit. Velocity values away from its point of origin or returning to its point of origin. So I'm going to be thinking, is this going to be moving right or left, or what's happening here? So in this one, is the function going to be, so if this is velocity, I can see that velocity is always positive. If velocity is positive, that means the function P of t is increasing, but it also means that V of t, if this is positive, that means the function is moving to the right as V of t is positive. So I'm going to say V of t, therefore, the plane is moving right away from its point of origin. And is flying in a straight line. Okay, the next one we said the function f is modeled by this f of t. And then it says, according to this model, what is the acceleration of the plane at t equals 23? So if I'm given this, what I'm really finding is f prime of 23, because this the function f is used to model the velocity. The derivative of velocity is going to be acceleration. But if I have my calculator, I'm going to use it. So I'm going to say math. I'm going to go to 8, and I'm going to say the derivative of this function, which would be 6 plus cosine of x divided by 10 plus 3 sine 7x divided by 40. And I want to find and evaluate the acceleration at 23. And I get negative. You can stop this and truncate it right here. If you wanted to say negative 0.408, that would be fine. So this one's saying the function here, according to this model, what is the acceleration? We're doing that, except for if this one was given miles per minute, we can also assume this one is in miles per minute. So, and it says it, miles per minute. I guess we shouldn't assume anything, but they are the same. So this would be miles per minute squared. And then it says, what does this value indicate about the velocity at t equals 23? If I go up here, velocity at t equals 23, we said, where was this one? Did we say this one yet? No, actually we can figure it out. Velocity at 23 would be f of 23. I don't even need to do that. I was going to do some stuff if it was talking about speed. If the velocity at t equals 23, if I see acceleration as negative, that means velocity is decreasing. As f prime of 23 is less than 0. Don't get this confused with speed. So if we're talking about speed, we would have to check whether both velocity and acceleration would have the same sign. If velocity and acceleration have the same signs, then that's when we know a particle speed is increasing. If they have opposite sides, the speed is decreasing. This is velocity. So two different things. So make sure that you're paying attention to velocity versus speed if you're talking about increasing or decreasing. Make sure that you're going through some of these other problems again and looking back over homework. If you let the homework go until last minute, it'll all be fresh in your mind. But people who did it along the way, I think it'll be a little bit easier in your, really just to stay in your mind than cramming it in all at once. So thanks, good luck, do awesome. You got this. I'll be around on Thursday morning, or at least I plan to be, unless there's like something crazy that happens. But yeah, good luck, do well, study lots.